Hello viewers, welcome to Just Studies Masterclass on Snowflake. Today we are in the masterclass we are going to see more on Snowflake features, Snowflake overview. This is the second session on Snowflake masterclass. If you have not seen the first class, please go to my channel, subscribe to my channel and go through the first session where we discussed about the Snowflake key features, key differentiator among the market, why it is so popular. So we keep it capabilities about Snowflake. We have seen that. Okay, let's start today's session. In this session, we are going to see Introduction to Snowflake, continuity to first class. It is features. We'll see more deep dive into the features part. Introductions to Snowflake features security. We'll see security part. Plus, we are going to see Snowflake architecture overview. As we've seen already in the Snowflake introduction part, there where we will be more talking about the features, overviews, scalability, pay as you go, security, the purpose of build, and the data, which data, how the data we have done. So just have a quick recap. Snowflake we can load the data, structured data, semi-structured data, unstructured data, and we can query with simple SQL. You don't need to write a use code, or you don't need to write any serialization has to be not to be done. So now moving to the features part, we have so many features. The features which we are seeing here is all of the features. I will be getting next session. In next section we will be get each feature. I will explain very deeply, and this is just a brief summary about the features. But in coming sessions we'll be having a detailed information about the Snowflake features. First part here is micro partition. So what is a micro partition? This deals with data part and the storage part. Micro partition, this is the micro partition part, deals with the storage part. We already seen in previous session. We have architecture part. If you see, it stores the data in centralized way. So micro partition, so it has unique feature. Snowflake stores the data in encrypted format, both in rest and transit, and it has stored the data in compressed columnar format, and it is a proprietary compressed format. So we'll see more on micro partition, and it stores the data in each partition can hold a maximum 16 MB uncompressed is compressed data and 50 to 500 MB uncompressed data. More details on micro partitions we'll see in coming session. Next we have a tables part. A tables as a Snowflake can be used as a data warehouse, or it can be used as a data lake. It can be used as a database, and if you have a database, definitely you have tables, you have an object, you have any schema, you have the schema holds the objects, table objects. So here Snowflake allows you to create a permanent table, transient table, temporary table, external table. Details about these tables, why they have so many tables Snowflake is providing to us, we'll see detailed session. But the summary part, permanent table, so whatever the table you create, whichever the table you create in Snowflake, by default it will be a permanent table, and the tables will be linked with the time travel. So time travel is again a unique feature where Snowflake is providing. It's linked with a time travel. So if you want to a time travel have it's like a continuous data protection, where if you have a data, if you accidentally you deleted your data, or you have performed some corrupted your data by performing wrong transactions, you updated data, so not to worry, Snowflake is there and you can retrieve your data in fraction of seconds. You can get that using a time travel feature. We'll see that in time travel feature, but the tables are linked with the time travel. So if you time travel is again a advantage, plus it associates with the cost. As we already know, Snowflake will charge you based upon storage and compute. So it falls under the storage cost. And how we need to use a time travel facility, and then we need to, plus we can not spend more. So that's why the Snowflake has bought a different types of tables. The permanent table, it attached with 90 days time travel. We'll see that detailing. And transient, it has a time travel, comes with a failsafe where the time travel is it provides a maximum 1 day to 90 days time travel. You can go back to 90 days data back, and you can retrieve the data as it. You don't need to perform any huge operations. You don't need to get it from the backup. Snowflake is doing for you that. Okay, so permanent table is basically whenever you create a default table in your database, then or in a schema of, then it is a permanent table. But if you want to create a transient table, temporary table, the temporary tables are like a session based table. It will be the span of the temporary table is very less. You have a time travel of only 1 day, but it can be as soon as you close your session, the table will be dropped. Okay, so it is a cost factor. You have a fail safe in a time travel. We'll discuss about that. So temporary table is like a cost cutting for you, and if you want to work in a session based tables and it is not important for you to storage, then you can drop that using a temporary table. You can create a temporary table. It's very simple. While you are creating a table, just create table, and you need to specify which type of table you want to create. If you don't specify anything, by default it is a permanent table. And transient table is also similar to a permanent table. Only factor here is it have a less time travel. Like you can, if you're creating a time transient table, it is having a only 1 day time travel. That means you can get always 1 day previous data. You can get 24 hours data from the name of the table it has been created. Plus it doesn't fall in the fail-safe region, so you can save the money here also. And they have introduced a external table. External table is basically, it is a read-only tables. It deals with your data lakes. If you want to bring a data from the big data platforms, or you have built a data lakes and you don't need to pull entire data into your Snowflake environment. Just you can create an external table on top of integrate between a data lake or big data tool and your Snowflake. And the external table normally holds the metadata information about the files in that data lakes. Okay, so whenever you need, and you can create a read on schema. It provides a read on schema, and you can load a needed data. So you don't need to worry if you have a big data, you have invested already in a big data, and you have data lake, and no need to migrate that into data warehouse of Snowflake. You can query directly from the Snowflake using an external table. So we'll see more details on this. That is a table part. And move to the views. View is again a object of a database schema. So here Snowflake allows you to create a standard view. Everyone knows the views, why we will create a view in traditional relational databases. How we create a view, similarly here, nothing new. You can create a view to hide your complexity, or you want to give a more security on a table. If you don't want to give entire if you are only few columns has been needed by your customer, and you don't need to give an entire table access to that particular person. If you are looking only few fields, or if you want to hide a complexity, like if you want to give a data to a customer where it will be getting data from multiple tables, so you can join those multiple tables, create a view top of that. It is like a one more layer of security you're creating and give to the customer, so that you can give an access to the view. So that is one. And it's apart from the standard, it gives you secure views. So there is a slight difference between secure view and standard view. I can describe like secure view is more secure than standard view. Views are already it is a kind of a security, but top of that you are again giving a secure views. So only difference I can tell in the secure view and standard view is in the standard views, if you have created a standard view and you have an access to the standard view, you can even see the DDL, the creation of the data description about that view. If you want to hide that, you don't want to make the user to know about what is the complexity, how it has been built, then you can create a secure on top of that. So normally if you are doing a sharing in the Snowflake, all the objects you are doing in a secure mode, so that it's a read only and secure for us. And plus it allows you to create a materialized view. Everyone knows the materialized views. There is a keen difference between a view and materialized view. View is called a virtual table, whereas a materialized view holds a data and it need a periodical refreshment. Okay, so once you create a materialized view in Snowflake, automatically the refresh will be happen backend by Snowflake. You don't need to worry, but it's again you need to be utilized wisely the materialized view. Whenever you create mostly the materialized views are created to uh, increase your performance on your external tables. You create a external table, then you create a materialized view on top of that and materialized view. So we'll see in detailed session on views. There we'll discuss about that materialized view. Next task here is we have a clustering part of a data. We have a search optimization. So next come to is search optimization of your data. Search optimization, and the search optimization is very like a you have creating a lookup. Like normally we'll do a lookup, right? Quick lookup on your data table. So it's mainly for a query performance tuning part. Search optimization, there are many techniques Snowflake provides you to for the query tuning. Like it provides you clusters. You can create a clusters on top of a table, the data which you have stored. And if you are not happy with the cluster, because the clusters can be created on only simple keys, maximum 3 keys you can take. But if you want to, the table is heavily used non-cluster keys, you can create a search optimization search on that, and it will be used for quick lookups. So that is a brief introduction of search optimization, but we'll have a complete session on that and you will know much deeper on that. Coming to this is a part of that cloning. So we talk about the clone. A clone is nothing but if you are performing here the zero copy cloning. It's called a zero copy cloning because you are not performing any data movement. It's like a simple backups. You're taking a backup of your data. Clone, I can put in simple words, that taking a backup of your data. Clone, that is a clone. So here Snowflake, you can create n number of clones. You don't have any limitation. Your data will be resist at one part and you are creating a multiple clone on top of that. It's like a snapshot at that particular point. And all this, it is like data movement has never happened. It is like a metadata operation. All the clones will be pointing to the real data in your storage layer. So that is a clone. You can create n number of clones. You don't need to pay for anything for creating a clones. It is not associated with any cost because the clone is only the metadata operation. It is a read and write. You can, once you create a clone on top of your table, you can create a clone on a schema, you can create a clone on a table, you can create a clone on a database, entire database. Once you create a clone, you can retrieve or query the clone as a normal table. You can read the data, and one more thing here is it allows you to write data also. As soon as you start performing any DML operation on your clone data, then it became a base table and you need to pay for the storage cost. So until that, if you are just using this as a read only clone, then it is no charge. You can create n number of clones on the base data. Time travel, we already discussed about time travel. So Snowflake has provided a time travel feature which is very important. It is provides a accidental it is like a savior for accidental things. Okay, if you have done any accidentally, you have deleted your data or you have done any updates, anything, then you can just bring back your previous data state. Okay. Time travel, you have maximum. Snowflake provides a 90 days of time travel, from 0 days to 90 days time travel. It has a time travel plus it has a fail safe. That means you can travel back to 90 days. You can just go back and travel and get the 90 days data and get back whatever the exactly point of time. So it provides, in the time travel, you can go at particular query in Snowflake. Whenever you fire a query, it create a, each transaction has a query ID, and you can retrieve that query ID and you can go particular point of time. So you can have a create an offset on particular time. So with the time, if you really know of which time the data has been get accidentally deleted or it has performed any wrong operation on your table, then you can use the time, or you can use a time frame, or you can use a query, the query based upon the query when it has been, or you can go there particularly and retrieve the data. You can just drop a data and undrop a data. It's as simple as that. You have time travel, fail safe. So what is the difference between a time travel and fail safe is, here the time travel is it's a 90 days bucket, and you can go to the, if you want to retrieve a data, you can do yourself. That is a self managed by yourself, self service. Whereas after the 90 days, it will enter into the fail safe. That is again an additional 7 days provided by Snowflake, and it will be with the Snowflake team. And whenever if you want to get, you need to request the Snowflake team, and Snowflake will get back your data, and that too 7 days. So ideally speaking, you have saving your data, you are doing a continuous data protection for 97 days. That means 90 days in the time travel phase, that is you can do your self-service, and 7 days is in the file save part where it is handled by Snowflake team. And it has, we already discussed, permanent table. You can configure your time travel from 0 days to 90 days. This time travel can be configured at account level, database level, schema level, and table level, granular table level. At the Snowflake recommends to not to change the account level, but you can tweak your, configure your database level. You can make it at Snowflake level, table level, schema level. That is the time travel. You can do it. Transient table and temporary table. Why this is a life changing? Because it is cost related to fail safe. You don't have a fail safe in the transient table and temp table, whereas permanent table will have in a fail safe. Next, moving to the another important part of the feature of this Snowflake is you are creating a share. So we already seen the share part. It is share is totally it's a secure sharing. Your data can be shared securely. The zero data movement. You need to worry. Here the only thing is the Snowflake share is your data is centralized at one place, and you can share the data. And the difference between the clone and share is, clone is you can perform the read and write on both clone table, whereas share is in a read only. So you can share the data, you can share the data with unlimited number of the consumers. You can, so data resists in only one place, though zero data movement, and you can share it to with a number of consumers. And sharing also, it is a beautiful concept the Snowflake brought. You have a provider and consumer. Even though you are not a you are not a Snowflake customer, and still you want to share your data, yes, you can share that data to the customers. You have a producer and consumer. As a part of, you are sharing a data, you are a producer, and the person who is consuming that is a consumer. So the billing the billing also it done very neatly. So you, even though you are not a Snowflake customer, you can share your data to non-Snowflake customers, and you can share to the Snowflake customers also. So for the Snowflake customer, anything you are, because here the cost related, the storage and compute, it will be depends upon the agreement between your consumers how you want to share it. If you are a non Snowflake customer, because he doesn't have an infrastructure, as a provider you have facility to provide him the infrastructure. You can give a access to your data, and the charges can be the billing will be happen on your same, the consumer billing and producer billing happening on the producer side only, and the producer has to be collecting the money from the or cash transaction between the consumer in another way. Whereas in the Snowflake customer, if he has a Snowflake, you want sharing the data to a Snowflake customer, already a Snowflake customer, then the consumer who is using that will be burning his own credits, and he just here the provider is providing you data that is a read-only data. Coming to resource monitor, now the resource monitor is like, as we see here, storage cost and compute cost. If you want to control the cost, like how you have a resource monitor, here the Snowflake provides you a monitoring system. You can monitor and you can control the costing, who can burn, which warehouse can execute more. You can divide that resource monitoring. You can do the resource monitoring, and you can create it provide a beautiful dashboard, and it shows you how much, where the data has been consumed, how much has been, where the credits has been consumed. It gives you details you can control using a resource monitor. Even it allows you to create a alerts, where you can easily, it notifies to the administrator about the credit limits as it is exhausted. It shows you, and it will notify 5 alerts, and finally fifth alert, sixth alert, it will start. So you can suspend it immediately, or you can suspend until your if your threshold has been reached. You can do that. We'll see details about that. Next, we have already discussed that Snowflake allows you to create your own functions. If you are not happy with the functions or your functionality, you are not able to achieve your functionality with the default stores SQL functions, you can create your own functions using a UDF stored procedures. It supports JavaScript, SQL, Java. You can write. Stored procedure supports the JavaScript, only JavaScript. You can use JavaScript, whereas UDF, user defined functions, will support a JavaScript, SQL, even Java too. It supports that. And coming to the data recovery part or data replication part, it seamlessly replicate across the region and across the cloud platform. So Snowflake will take care of that. You don't need to worry on that. Snowpipe is like automation data ingestion. So if you want to, it like, unlike the copy command which is used in virtual warehouse, Snowpipe is entirely a serverless process. All features we are discussing will need your server, that is a compute power, so it been charged on the compute power. But Snowflake is entirely a serverless process. Snowflake manages this operation entirely, and it scale out and compute as needed. So Snowpipe allows you to perform the CI/CD in this. Automate data ingestion can be handled using a Snowpipe. We'll see more details on this. Streams, if you want to handle the change data captures, the streams are the Snowpipe will enables loading data from files as soon as they are available in the stage. Okay, so Snowpipe can load the data from files in micro batches, make it available to user within a minute. And coming to change data capture, you can perform the change data capture using a streams and tasks. So task here is like a scheduler. It is a scheduler. If you want to automate your processes, you can create a task on top of that, and you can schedule that, and you can use the task. And your CDC, here it is change data capture. For any data virus, it is very important to have a CDC, right? So mechanism for bigger table. Okay, so it is change data model is required so that you can load only the change data. So you can achieve in the using a streams task. So entire CD data pipeline, if you want to create a data pipeline, you can achieve this by using a Snowpipe, stream and task together. You can create a, plus using a store procedure, you can create a complete data pipeline using Snowpipe using Snowpipe, using streams, using task, and using the UDF store process, a complete pipeline can be created in Snowflake. And continuation to features of Snowflake. Snowflake provides auto clustering, so you can, as we see, that it stores the data in micro partition. It is proprietary micro partition. It is compressed uh, columnar partition. The data will be stored in compressed columnar partition. It's a proprietary Snowflake. So if you are not happy with the way how the data has been stored and how the data is retrieved, because you don't need to maintain, you don't need to worry about the performance. That is a key feature of again Snowflake. But still you want to perform a cluster. So if you are not feeling your data is getting, your queries are taking long time to run, then you can create a cluster. So Snowflake support a natural clustering, and it supports a user-defined cluster. Natural cluster is based upon the data ingestion order, the data how you order, ingest the data. Based upon that, it will create a natural cluster. If you are not happy with the natural cluster, you can create a cluster using a cluster ID. You can create a cluster IDs. Maximum you can take a three clusters, three keys to create a cluster key, three columns as a cluster key, and it is for mainly for efficient pruning of the partition. And one more good feature of the Snowflake is, as soon as you create a cluster, you don't need to worry about the reclustering. So reclustering will automatically happen, auto clustering, it will happen, and you don't need to worry about the auto clustering. Snowflake will take care, but here it deals with the storage and compute. You need to bear the cost. Materialize wise, we already saw that materialized view you can pre-compute for a faster access. You create a materialized view. Snowflake is both having a multi-cluster. You can create a MPP framework for your scale-out processes. Like if you want to have a concurrency workload, you can use a multi-cluster. And for your this one, you can use the we have multi-cluster. It support a multi-cluster for concurrency and performance. It will support, you can increase the Snowflake will come up with warehouses, where we will see that completely details about the warehouses in coming session. It follows the T-shaped, T-shirt shaped warehouses from the extra small to 4XL. You can use that, increase the power by using that. So you can have a multi-clusters you can create. We'll see how we can create. And coming to the governance part and security part, a Snowflake will provide you row level security, column level security. So column level security can be achieved by using a dynamic data masking policies. So these are the generic policies. You can create a policy on column, the column which it can be on data types. You can create it and you can reuse that policies. So you need to create that your policies on the particular column, apply that policy on that table, and you can control the data, who can see the data. So your sensitive data can be easily secured by using a column level security. It allows you the low level security. You can create a row level access policies. You can create this similarly to the column level access policies. You can create a row level access, so that based upon the access authentication authorization, you can provide them that one. The marketplace is again a very beautiful one. So you can exchange your data as a part of a sharing. You can do a public share or private share, that is a marketplace. You can do a public data exchange. You can share your data to the community, or if you want to share the data in private mode and secure way in the intranet, data sharing can be done using a private data exchange. You will have a query acceleration. You can add extra burst for large scale of EDA. If you want to perform a external data exploratory data analysis, you can perform in Snowflake. These are all the features. Day by day, Snowflake is adding more features to this Snowflake environment. We'll see more details on features, each feature, and all this in coming session. Viewers, I am going to explain each feature. Detailed sessions will be there, and please please subscribe my channel and please share and like my videos so that I can go and create more videos on this. And thank you very much for attending this session. We'll meet with next session about with overviews, architecture, and security features. Thank you very much.